Swayam Prabha. Digital India. Educated India.
Hello and welcome back once again. So we have been discussing about dynamic recrystallization, and we have seen that there are three forms of dynamic recrystallization: DDRX, CDRX and GDRX.
So while discussing about the mechanism of DDRX, we have seen that first, dislocation density gradients are developed near the original grain boundaries due to the incompatibilities between grains. This is accompanied by subgrain formation, eventually leading to the development of boundary corrugations or serrations. So now if you look at the evolution of this entire process as to how it progresses once the serrations form on the grain boundaries, first at lower strengths, the grain boundary sliding can take place, the grain boundary sliding or migration as we were talking about. And as the serrations develop, this will prevent further sliding of the grain boundaries. Leading to development of additional strain gradients and thus further increasing the driving force for recrystallization. That can be represented with a diagram like this. So if we call this one as the first stage, then the second stage will be this, that is, development of additional strain gradient due to the prevention of the grain boundary sliding by the serrations. So we can call that as stage 2, and it can be represented by a diagram like this. Right, so this kind of corrugation or serrations will be developed as the strain gradient across the boundaries increases, and finally it will lead to formation of the bulge. So that's the next stage. Right, so the bulging will occur due to this, as I said, which is depicted by this diagram. And the nature of the boundary which will form along these bulges, that would depend on the value of Z, as I said before. When you have high Z, then these boundaries will be the strain-induced sub-boundaries. And for low values of Z, you will have formation of twin boundaries. And the condition for the bulging can also be described by a mathematical expression of this form. Where delta E is the strain energy difference per unit volume across the boundary, gamma B is the grain boundary energy per unit surface area, and L is the length of the boundary before bulging. And K1 is a parameter whose value is typically less than 1 under DDRX condition. Right, so this is how the nucleus during the DDRX process forms with a mechanism like this, where the grain boundary bulging leads to the nucleus. So now let us see the next form of dynamic recrystallization, that is continuous dynamic recrystallization, or CDRX. So unlike the DDRX process, here in case of CDRX, there is no predefined nucleation and growth stage. And the strain-free grains rather form by a mechanism which leads to progressive increase in the misorientation across the boundaries, which form due to dislocation rearrangement. Okay. So CDRX involves a progressive transformation of dislocation subboundaries into high angle boundaries leading to the formation of the strain-free grains. And how this progressive transformation occurs, that is what we are going to discuss, as to what exactly happens during this and how the nucleus forms when you have conditions which are more favorable for CDRX rather than DDRX. Okay, so CDRX will have to involve rearrangement of dislocations into low angle boundaries or subgrain boundaries. And the process evolves through the increase of the misorientation across these boundaries. Okay, and in order for the misorientation to increase, more and more dislocations have to come and join these boundaries. Dislocations have to accumulate along these boundaries, and you would also need some lattice rotation in order to increase the misorientation further, so that these low angle grain boundaries can develop into high angle grain boundaries and you can form the recrystallized grains, right? So therefore, CDRX will be more prevalent in materials having high stacking fault energy, because here you need the cross slip and climb motion of dislocations for them to come and join these boundaries for this to be converted into high angle grain boundaries, right? So DDRX we have seen it is more prevalent for low stacking fault energy materials, but CDRX on the other hand will be more dominant in materials having high stacking fault energy, because here you need the cross slip to occur. Okay. So as I said in the beginning, stacking fault energy plays a very important role in dynamic recrystallization, because this, as you could see now, this decides the mechanism which will be dominant during the process, whether it will be through a discontinuous kind of process involving nucleation and growth, or it will be a continuous kind of process involving progressive increase in the mesorientation across the boundaries formed by dislocation rearrangement. Okay. So there are some mechanisms which are proposed for the nucleation that occurs when the conditions are favorable for CDRX. And one of them, as I said, is through the progressive increase in mesorientation. Progressive or gradual increase in the mesorientation. As I was talking about, so let's say, these are the grain boundaries, the existing grain boundaries, which are delineated by these black lines that you have over here. So as you deform the materials, dislocations will be generated, and they will tend to rearrange themselves into low energy configurations such as sub-boundaries, right? So when you deform the material, you can have the dislocations being arranged into this kind of boundaries. So dislocation substructures will be formed, and this is something that we have seen while discussing about cold working also. When the material is cold worked, dislocation density is increased and dislocation substructure and cells can form. So this is a similar kind of phenomena leading to the arrangement of the dislocations into some low energy configuration. So when you have conditions of high temperature, then the dislocations can actually rearrange themselves into sub-grain boundary kind of configurations. And this phenomenon is known as dynamic recovery, like what we have seen before, the recovery process. In this case, it happens at high temperature during deformation, leading to formation of this kind of subgrains inside the grains. Right? So when you have heat being applied simultaneously, contrary to this kind of cold worked structure that you might have when the material is deformed at cold conditions or at temperatures below the recrystallization temperature, you will have this kind of well developed dislocation substructures with this low angle sub-boundaries formed by the dislocation rearrangement. And that's the dynamic recovery process, as I said. So the CDRX occurs by progressive increase of the mesorientation across these boundaries. Okay, so this black boundary that you see over here, the black line, that represents the high angle grain boundaries. But the boundaries which are formed by these dislocation structures, these are still low angle. So in order to convert them into high angle boundary, more and more dislocations have to be absorbed into these boundaries, and ultimately you also need some lattice rotation to occur so that these boundaries can be converted. First of all, the misorientation across these boundaries can be increased, leading to their conversion into high angle boundaries. Okay. So as you deform the material, more dislocations will be generated and will be absorbed in these boundaries, and the misorientation across these will increase, and it will also involve some kind of lattice rotation. Which will eventually lead to conversion of these subgrain boundaries into high angle grain boundaries. So these boundaries which are given in red colors, these are actually those boundaries which have now been converted into high angle boundaries. So you can say that these are the strain induced high angle boundaries, which are generated due to dislocation accumulation and lattice rotation. And now these grains that you have generated due to this process, the grains which are bounded by these high angle boundaries now, these will be those new strain free grains, right? Because now the dislocations have taken part in a process like this, joining the grain boundaries and increasing the misorientation across them. And therefore the grain interiors will be free of dislocations and the material will be recrystallized. And in fact, the grains which are generated due to this process will be also finer. So at the end of this process, you will get a recrystallized fine grain microstructure. Right, so this is also a process which is conducive for grain refinement. So we are going to revisit this topic again when we talk about grain refinement, because as I said, this is one of the mechanisms of grain refinement also. When the material is deformed at higher temperature by large strain, I mean when you severely deform the material at high temperature, this kind of phenomena can occur and lead to a fine grain microstructure. So this can also be a mechanism, a technique for grain refinement. And as I said, we are going to come back to this when we actually discuss about the grain refinement process. Okay. So to summarize these two forms of dynamic recrystallization, DDRX and CDRX, we can say that the DDRX process occurs in conditions when dislocations can accumulate to generate a gradient in dislocation density or strain energy across the grain boundaries to form the nucleus. Okay. So this is a process which will be more dominant in materials having low stacking fault energy, because in such materials only dislocations can accumulate, because low stacking fault energy means less cross slip, and as a result of that the dislocations will not move much and accumulate, giving rise to a high dislocation density in certain regions of the crystal that will lead to a strain energy gradient across the grain boundaries, which will ultimately drive the nucleation process. And the dominant mechanism for the nucleation in case of DDRX is the grain boundary bulging mechanism, where we have seen that due to the development of dislocation density gradients across the boundaries, conditions are generated for the bulge to form, and this can act as the nucleus. And we have also seen the boundaries which form around this bulge, or the nucleus which forms out of the bulge, will depend on the Zener-Holloman parameter. For high values of the Zener-Holloman parameter, the boundaries will be low angle boundaries, while for low values of Z, twin boundaries will be generated. CDRX, on the other hand, occurs by a progressive transformation of the dislocation subboundaries into high angle boundaries, and this process involves accumulation of dislocations along the subgrain boundaries formed by dislocation rearrangement, followed by lattice rotation, leading to an increase in the misorientation across these boundaries and turning them into high angle grain boundaries. So the process through which the dislocations rearrange themselves in subgrain boundary configuration is known as the dynamic recovery process. So this is basically dislocation rearrangement into low energy configurations. And for this to happen, the dislocations have to cross slip for them to be able to join these boundaries. And therefore, CDRX will be prevalent in materials having high stacking fault energy, which promotes cross slip of dislocations. Right? So once these boundaries formed, more and more dislocations will be accumulated along these boundaries and will increase the misorientation across them. So these boundaries will progressively turn from low angle boundaries to high angle boundaries, and eventually a lattice rotation takes place which converts all these boundaries into high angle boundaries, giving rise to the recrystallized grains. As you could see from this particular diagram over here, the process of evolution of these subgrain boundaries into high angle boundaries is depicted. So at the end of the process, you have these strain induced high angle boundaries which have evolved from the dislocation subgrain boundaries generated due to the arrangement and accumulation of dislocation into low energy configuration. So these are the two dominant forms of dynamic recrystallization, and we also have some other mechanisms for the CDRX process. Like in this case, we said it is through the progressive increase in the misorientation. So that gradual increment can also occur by another mechanism, which we are going to discuss next.
But I think for now, this is all I have. So I'll stop here today. Thank you for your attention.